everyone, welcome back to the Introduction to Data Science using Python series with Shambhavi. Today, we're diving into one of the most widely used unsupervised machine learning techniques, that is k-means clustering. In this session, we'll cover the basics of k-means clustering, implementing k-means clustering on a real-world dataset. I'll explain each slide in detail, go through the Python code, and interpret the outputs. So, let's get started. K-means clustering is an unsupervised machine learning algorithm used to group data into clusters based on similarity. Now, what is clustering? Clustering is grouping similar data points based on patterns and characteristics. Its applications are market segmentation, customer behavior analysis, image compression, and anomaly detection. Here's how it works. We define the number of clusters k beforehand. The algorithm randomly initializes k centroids in the feature space. Each data point is assigned to the nearest centroid, forming clusters. The centroids are recalculated as the mean of all points in a cluster. Step 3 and step 4 are repeated until the centroids stabilize or a maximum number of iterations is reached. This iterative process minimizes the intra-cluster distance while maximizing the distance between the clusters. Let's move on to our application, that is implementing k-means clustering on a dataset. In this example, we'll use the iris dataset, a classic dataset in machine learning. Here's the Python code for clustering and visualizing the results. Now, here's what's exactly happening in the code. We load the iris dataset, which contains features like sepal length, sepal width, petal length, and petal width. We initialize the k-means model with 3 clusters as the iris dataset has 3 species. After training, we assign each data point to a cluster. Finally, we plot the results using a scatter plot. The output scatter plot shows distinct clusters in different colors, representing the groups formed by the algorithm. Here's what the output will look like after implementing the code that we discussed above. Now, let's interpret the results. Cluster assignments. Each data point is assigned to one of the 3 clusters. These clusters represent groups of flowers with similar features. Centroids. The centroids of the clusters represent the average feature values for each group. Looking at the scatter plot, we see that the clusters align with the natural species present in the dataset. This demonstrates how k-means can reveal hidden patterns in data, even without labels. Before we wrap up, let's quickly discuss the pros and cons of k-means clustering. Its advantages include: it's simple and efficient, making it suitable for large datasets. It works well with data that forms spherical clusters. Limitations: it requires pre-specifying the number of clusters. It's sensitive to outliers and may struggle with non-spherical clusters. Understanding these limitations helps us decide when k-means is the right tool for the job. And that's a wrap. Today, we explored the theory behind k-means clustering, implemented it on the iris dataset using Python, and determined the optimal number of clusters. If you found this video helpful, please give it a thumbs up and subscribe to Shambhavi Manjrekar for more machine learning tutorials. Let me know in the comments if there's a topic you'd like me to cover next. Thanks for watching, and I'll see you in the next video.